This is Mike Thaman, and I'm taking a little time to make a video to show my experiences building my own CNC router. These plans were obtained from the April, May, and June-July issues of Woodsmith Magazine of 2019. So here's a picture of the business end of the CNC, and you see in the middle there a large motor which will drive the router crane up and down the table. And you see an emergency stop switch. You also see a power supply and a cooling fan that draws air through the entire electronics box. And here's a picture of the router crane with the router there in the middle, and on the left side that would be the Y-axis drive, and at the top would be the Z-axis drive motor. In the 8 or 9 months I've had this router, I've made many improvements, but that's not to say there was anything really wrong with the basic design. It was very robust and accurate, and turned out quality pieces since day one. Let me just take you on a walk around and show some of the changes that I've made. You might notice that the table now has 12 circles in it. They're actually posts that were surfaced off to give me a dead level reference to re-level the spoil boards, because eventually you'll realize you can't have a table that is too level when you want to throw something up on the table and do a quick project and not have to fiddle with shims and things like that. And here you will notice that I put filters all over all the inlet air holes. You may find out, like me, that you don't want to run a vacuum the entire time the CNC is running. Depends a great deal on the kind of work you're doing and how much dust your shop can tolerate. And probably the biggest improvement I've made is to put a 3-pole single throw switch on the Z-axis motor and a larger knob. This enables you to run the Z-axis down by hand until the bit just touches the surface so you can set your zero. This is an enormous improvement over trying to jog to set your zero. Putting a hinged door over the electronic controls makes a big difference when you're trying to set up the machine and changing jumpers and things. It also helps later on when you have to clean in there. And I have 3 drawers, one of them strictly for router bits, one for cords, cables, calculators, remotes for the router, things like that, and the other one for hold down pieces. And here's the hold down hardware. It's all 1/4 inch. It's all threaded into a metal plate. I happen to braze them on, but you could use Loctite if you can't braze. Color coded for length with various knobs. And here's a stack of the hold downs that I don't keep in the drawers, but I keep underneath. I'm on revision 3 or 4 on the router backplane. I finally settled into a large router that will take a 1/2 inch bit and then sleeving the smaller routers into the hole. This allows me to switch routers very quickly without having to realign anything. This new backplane also uses jack screws to give you a micro alignment feature so that you can absolutely make sure that the router is perpendicular to the table. And last but not least is a set of whiteboards. The most important one is the one at the right. When you take a break or go to lunch or something like that, you write down exactly where the table is at. I went to supper one night. I thought I had Windows updates turned off. When I came back from supper, Windows had updated and shut itself off. It took me over a 1/2 hour to get the table back in the position where I could continue the cut. And no, when Bill Gates comes out with his COVID vaccine, I will not be in line to get it. My grandson caught an 18-inch albino catfish when he was about 7. I was able to find a bitmap on the internet and make him a catfish plaque early on. This was the very first money-making project I did. I had a friend that saw what the CNC could do, asked me to turn out a heart with the name Cecilia in it, which was one of the names of his adult daughters. And so I did that. Notice that I did not pick the best wood. I just picked the best spot out of a piece of wood. I sped this clip up so it's actually looking like it's running at 6 times the normal speed. The CAD software that I'm using is called CAMBAM, and it's written in England, and it allows you to make tabs so that this doesn't cut all the way through, all the way around, so the piece doesn't come flying out when you get to the bottom. As you can see, it turned out quite nicely. The buyer decided to stain and finish it himself. This is an 18 by 36 inch sign that I did for a restaurant in Glandorf, Ohio. and learned a lot about cutting on soft woods. It must be done with a downcut cutter because the wood fuzzes so bad. When I got it done, I painted it with a paint-on masking, then painted the various colors and then peeled the masking off. You cannot mask it first and then cut it. I will only describe that as cutting through a field of rubber bands with a dull mower, and I'll leave the rest to your imagination. I have a neighbor who's had a lot of surgeries, and his wife wanted this made so that they could put it next to his urn when he dies and is cremated. Seemed sort of morbid, but they saw it and they thought it was cute, and the good news is he's still alive. Here's a plaque I made for my son's screen printing business, and also a nameplate I made for his wife for her desk at work. For our other son, I made him a nameplate for his desk, but I made it look like the wood had actually been pushed through by doing a reverse on the second side. Let's take a quick look at the Mach 4 CNC software as we were cutting that heart out and leaving those tabs to keep the piece from flying off the table when we finally cut through. So after you design something with the CamBam software, it feeds machine code to the Mach 4 software to run. And this is a very busy screen. There's a lot happening here. So in the center left is a box that shows all the lines of code being read and interpreted, line by line. At the same time, in the upper left are the positions X, Y, and Z of the cutter at that exact instant in time. So you see, as the cutter is moving around the heart, you see the X and the Y positions are constantly changing. But the Z position, that is the depth of cut, stays the same until it changes each lap it goes around the heart. I pick it up here at 420 thousandths deep, and yes, it really does measure to the nearest 10,000th. So it reads 4,200 10,000ths. And here, as we approach a tab, it picks the cutter up, and it will pick it up to the same point each lap, so that it doesn't cut any deeper into the tab. There you could see that it was cutting to a depth of 420 thousandths deep, but when it got to the tab, it brought the cutter back up to 350 thousandths deep. And as soon as it got past the tab, it dropped the cutter back down to 420 thousandths deep. Now we've gone another lap. The cutter is deeper. Fast forward to where we're at that same tab position. Notice how it will raise the cutter to the same spot so it doesn't cut any deeper into the tab. This happens so fast that you don't really know what number it stops at, so I have frozen the frame to show that it really does go back up to 3/500ths of an inch. The most popular thing that I've done since I built the CNC is these personalized drink coasters. So I will run through some of these, and I'm going to speed some of them up. You might be stunned by a bit of dead air here, but I had a choice between either putting the router sound in there or singing, and I've been told they sound about the same. Since I do so many coasters, I've got a template set up, and let me show you how this works in the Kanban software. So realize that I've tweaked this over a year now, and I know what looks good and what doesn't. So what you see here is actually the result of much trial and error. So the first thing I've done is to draw some text into this for the capital letter. And I've worked with this for a while, and I've chosen the Dubois font, and I know what size looks best. You in fact have available to you all of the Windows True Type fonts that you have on your computer as choices. Now I need to cut that letter off so it doesn't intrude on the inset box that is going to have the name inside. So here's how I do that. I copy and paste that box, and then I enlarge that box to 112% of the size of the original inset. And then I use that new larger box to trim the capital letter. Once I'm done trimming, then I can get rid of the larger box. Now I just have to draw line segments across those open parts of that capital letter M so that they're connected. And as you can guess by this time, I have a pretty good collection of capital letters already done, so I just need to modify the inset. Now that I've closed up the sections of that letter, I just need to combine them into those sections so that each segment has one line. So I click on the 4 segments of that upper left-hand part of the M, and I join them together into one line. And I do exactly the same thing for the remaining 4 sections of the capital letter. Now you can never recombine those 5 sections of that capital letter M, but the software enables you to group them together and route them all at the same time. And now if you go back and look, there's still a text there where the letter M was, but nothing's there. When you delete it, you don't delete any part of this new letter that is now 5 separate sections. Now we can go ahead and create what's called a pocket. That is an area that the router cleans out, starting at the inside and moving out. So here we're filling in those parameters of 2 cuts of 8 thousandths and a final cut of 4 thousandths to total 20 thousandths deep. And it's going to ask you to pick the cutter as well. And it does all calculations based off the diameter of that cutter. And here I've chosen the 1/8 inch diameter 1 flute cutter. Now, of course, I already have the outlines that are to be engraved that are standard to all the coasters that I make. And now I pull a drop down and ask it to tell me what all the tool paths are going to look like. I'm going to turn off their view for a moment while I finish out the inset name. Now I've determined from trial and error that the CAMBAM 3 font works best for engraving single letters on these coasters. And that was a free downloadable true type font on the internet. And of course, just like the capital M, this word is available to move or to resize as you see fit until such time as you may choose to break it up into letters to modify shapes of individual letters. I found the font as delivered is pretty useful. I don't do much changing. And you need to engrave these letters rather than pocket them, so here I am setting the depths of 8 thousandths cuts, and of course choosing a very pointed tool. And of course, if you choose engrave, it doesn't much care what the diameter of the tool is because it will do whatever the tool is designed to do as far as angle and depth. So here I'm showing the 2 engraves that I already had set up, plus the new one that we just designed using the inset box letters. Now it will generate code to cut in the order in which those things are there. So if the pocket's right in the middle between 2 engraves, it's going to stop and ask you to change the tool. And you don't want to do that, so you just simply move it to the top or the bottom of the list so that all the engraves are done together, and then the pocket, or vice versa. Now you can click the drop down and ask it to generate tool paths again, and you'll see that everything here is included in some kind of cut. You can even call it out and ask it to generate the tool path widths to see what each cut is going to look like. It even uses little arrows to show you the direction that the cutter is going to be traveling at that point. Now let's just say, as sometimes happens, I don't have a 4-inch square, I have a 3 7/8 blank. I can change the size of this whole thing very easily. Of course, that means that the tool paths as shown on the screen are not over the lines that they're supposed to be, so you just regenerate that tool path. It'll put them in the right place. And of course, the final step is to produce the machine code called G-code. So in drop down, you do that and just ask it to produce it, give you choices on what to call the file. And just that quickly, it has compiled the code. And if you read it into the Mach 4 software and take a look at it, you'll find out that it's spit out 1,254 lines of code to run that coaster. And as the Mach 4 software reads it, it also maps out the tool paths, which simply followed the CAMBAM program's instructions. On the coaster we just showed, I used the 2 bits on the left, the engraving bit on the far left, and in the center, the single flute 1/8-inch bit. On the right is the 2 flute upcut bit that can cause a lot of fuzz. It also can leave some very fine marks. Here's a close-up of what I mean by that. You notice the first picture of the engraving is very fine and tight in hardwood. This first recess picture is cut with the 1 flute 1/8-inch cutter. Notice how smooth it is. And the second one was cut with the spiral upcut, and notice it's smooth, but it still has some lines. You can see where it was tracking. I'm a board member of the local astronomy club, and so I made them a plaque for the meeting room. In the upper right is the Big Dipper with all the stars in the constellation. Lower left is Saturn, and notice you can engrave outlines of fonts as well. I just pocketed the capital letters, which is our abbreviation for the society. I made a set of drink coasters for the local Christian radio station just down the road and used a radio tower as the highlight in the middle. I hope you've enjoyed this short video. My contact information will follow if you have questions. I encourage you to not think of this project as too complicated to handle, and you'll save about 2/3 of what you can buy one of the same size for. I built this unit for about $1,500, software included. The end. Thank you for watching.